Imagine an artificial intelligence system that does not just answer questions, but plans its own steps, decides what to do next, checks its own work, and keeps improving without being told each time. This is not science fiction anymore. This is Agentic AI. In this video, you will clearly understand what Agentic AI really is, how it works behind the scenes, what its building blocks are, how workflows are designed, and how intelligent agents cooperate to solve complex problems. By the end, you will see why Agentic AI is becoming the foundation of next-generation artificial intelligence systems. Agentic AI refers to artificial intelligence systems that can act as independent agents. Instead of simply responding to a single prompt, these systems can plan actions, make decisions, use tools, evaluate outcomes, and adjust their behavior over time. An agentic system behaves more like a problem solver than a question-answering machine. For example, instead of asking an artificial intelligence to summarize a document, an agentic system can decide to search for documents, compare sources, extract insights, verify accuracy, and then produce a final result. The key idea is autonomy. Agentic AI systems are designed to think in steps, not just produce one response. Traditional artificial intelligence systems are reactive. They wait for input and then generate output. Once the output is given, the process stops. Agentic AI is proactive. It can continue working toward a goal across multiple steps without constant human instruction. For example, a traditional system may answer a question about market trends. An agentic system can analyze data, identify missing information, request additional data, test assumptions, and refine conclusions automatically. This ability to reason over time makes agentic AI more powerful and closer to human-like problem solving. Agentic AI systems are built from several foundational building blocks that work together. These include goals, memory, reasoning tools, feedback mechanisms, and control logic. Each block plays a specific role. Goals define what the agent wants to achieve. Memory allows it to remember past actions and information. Reasoning helps it decide what to do next. Tools allow it to interact with external systems. Feedback helps it learn from outcomes. When these blocks are combined, the system becomes capable of autonomous behavior rather than simple responses. Every agentic system starts with a goal. The goal defines success and gives direction to the agent's decisions. Without a clear goal, the system cannot prioritize actions or evaluate progress. Goals can be simple, such as completing a task, or complex, such as optimizing performance over time. For example, an agent designed to manage customer support may have a goal of resolving issues quickly while maintaining customer satisfaction. The agent continuously measures its actions against this goal and adjusts its behavior accordingly. Memory allows an agentic system to store information about past interactions, decisions, and results. This memory can include conversation history, previous mistakes, successful strategies, and contextual knowledge. Memory helps the agent avoid repeating errors and improves decision-making over time. For example, an agent managing a project can remember which approaches worked well in earlier stages and reuse them later. Without memory, the agent would behave as if every interaction were happening for the first time. Reasoning is the thinking engine of an agentic system. It allows the agent to break a goal into smaller steps, evaluate options, and choose the best next action. This process is continuous. After each action, the agent reasons again based on updated information. For example, if an agent is planning a travel itinerary and encounters unavailable flights, it reasons about alternatives instead of stopping. This iterative reasoning process makes agentic systems flexible and resilient. Agentic AI systems often rely on tools to perform actions beyond internal reasoning. Tools can include search systems, databases, calculators, scheduling systems, or communication channels. Tools extend the agent's capabilities and allow it to gather information or take action in external environments. For example, an agent tasked with research can decide to search for new data, compare sources, and organize findings automatically. The agent chooses when and how to use tools based on its goal. Feedback is critical for improvement. After each action, the agent evaluates whether the outcome moved it closer to the goal. If the result is unsatisfactory, the agent adjusts its strategy. This feedback loop allows continuous improvement without human intervention. For example, if an agent generates a report that lacks clarity, it can recognize the issue and revise the structure. Over time, this process leads to more accurate and reliable behavior. Agentic workflows define how tasks are sequenced and managed. Instead of following a rigid script, agentic workflows are dynamic. The agent decides the next step based on context and feedback. For example, a content creation agent may plan an outline, draft sections, review quality, revise weak parts, and finalize output. Each step depends on the results of the previous one. This flexible workflow enables agents to handle complex and uncertain tasks. Some agentic systems use a single agent, while others use multiple agents working together. In multi-agent systems, each agent has a specialized role. One agent may gather information, another may analyze it, and another may validate results. These agents communicate and coordinate to achieve a shared goal. For example, in a business analysis system, one agent collects data, another interprets trends, and another prepares recommendations. Collaboration improves efficiency and accuracy. Agentic AI is already being used in areas such as research assistance, customer support automation, software testing, planning systems, and decision support tools. For example, an agentic research assistant can independently gather information, summarize findings, verify accuracy, and update conclusions as new data appears. These systems reduce manual effort and enable humans to focus on high-level decisions instead of repetitive tasks. While agentic AI is powerful, it must be designed responsibly. Autonomous systems need clear boundaries, monitoring, and safety checks to avoid unintended behavior. Designers must ensure agents act in alignment with human values, business goals, and ethical considerations. Transparency, oversight, and controlled autonomy are essential to ensure that agentic systems remain beneficial and trustworthy. Businesses.